Today we are starting chapter 2 with segment bisectors. Our objective will be to bisect a segment and to find the coordinates of the midpoint. We will spend a couple days on this lesson. Our warm-ups for today. First we are solving equations. On number 1, how did we solve? Brandon? We divide both sides by 7. And we get z equals 7. Number 2. Keon? I'm sorry? I want you to tell me how you got the answer and then what the answer is. Okay. Good. It is. Okay, so we had to add the 4 first to both sides, then divide. We get x equals 11. What about number 3? Subtract 5 from both sides, and we get y equals 22. All right, down at the bottom, this is something that we will see later on today, something similar to this. We're just plugging in the x to the x, the y to the y. Our answer is going to be an ordered pair. So I'll kind of make a little space to show some work up here. So if I plug in a 2 to this x, I would have 2 plus 2, which is what? 4 over 2. That comma just stays in the middle there. And then if I'm plugging in a negative 1 to that y, negative 1 minus 1 gives me what? Negative 2. It's still being divided by 2. So to get my final answer, I'm going to simplify both of these fractions. So 4 divided by 2 is 2. Negative 2 divided by 2 is negative 1. So our answer is an ordered pair. So I wrote my answer down below. That was just like my in-between step I didn't have room for. On number 5, we're doing the same thing. So I've got 2 minus 4 in the numerator. What's 2 minus 4? Negative 2. That over 2 stays in the bottom, comma. Negative 1 plus 5 gives me 4, still over 2, still written in parentheses as an ordered pair. And again, we just simplified both of these, but this time they're in a different order. So this time I would have negative 1, comma 2 as my answer. So the answers to these are points. They're ordered pairs. We don't do anything with those numbers once we find them. All right, our definitions for today. The first two, well, actually all 3 of them really are very similar, very highly related. First, to bisect. It's a verb. It means to divide into 2 congruent parts. So you split it into 2 equal pieces. A segment bisector is any object that intersects a segment at its midpoint. So it could be a segment, a ray, a line, or a plane. Anything that splits it at its midpoint. The midpoint is the point in the middle, basically. So that point divides the segment into 2 congruent segments. There is a formula that we use when we're given coordinates. So if we were given 2 points labeled x1, y1, x2, y2. Okay, I exaggerate my commas on these just to make sure we can see the numbers. If we were given 2 points, the point in the middle of those we would find using this formula. If K is the midpoint, then these 2 pieces have to be congruent to each other. The midpoint is directly in the middle. It bisects a segment. So FK and KG have to be congruent or equal in length. If the whole thing is 18, how long do you think each of those segments has to be? 9. Very good. We just split it in half to get those two pieces. On number 2, we are told that M is the midpoint. So again, M is directly in the middle. I could mark these. I'll use 2 little tick marks. Those two segments are congruent to each other if they have the same number of little tick marks on them. Okay, if JM has a length of 7, then ML should have a length of 7. If they're congruent, they ought to be the same. What about the whole thing, J to L? 14. We use that segment addition postulate to get the whole thing. All right, in this diagram, the line S is a segment bisector of segment FH. So that means that where it crosses FH, that is the midpoint right there. It is bisecting it at that point. So our goal is to find the value of X. So what do I know about these two pieces of FH? If this is the midpoint. This length and this length. That C word that we learned in geometry. Congruent. Okay, those two pieces are congruent if it's being bisected. There's a segment bisector. If they're congruent, that means that they should be equal in length. So I can set up an equation that says 3x plus 5 is equal to x plus 11. If two things are congruent, you can set them equal to each other. Then we just need to solve. So I'm going to subtract x from both sides and subtract 5 from both sides. That gives me 2x equals 6. Then to get x by itself, I'm going to divide x equals 3. Oh, it's a little hard to see that over there. And that was it. We were just asked to find the value of x. We don't have to plug it back in to find any lengths. All right, it's the same situation as before. We've got a segment bisector. We have some expressions. We're asked to find the value of x. If we have a segment bisector, that means that these two sides are congruent to each other. So I can mark them with little tick marks if I want to. If they are congruent, I can set them equal to each other. Congruent means they have the same measure. So I set up an equation, and then I use all of those algebra skills from last year or the year before to solve. Okay, so I'm going to add x to both sides to cancel those out. I add 5 to both sides to cancel these out. I'm left with 3x equals 21. When I divide, I get x equals 7. There we are. We were only asked to find the value of x, so we don't have to plug it back in. Okay, in order to find the coordinates of the midpoint, I first need to remember my midpoint formula. So that is good, x1 plus x2 over 2, comma, very good, y1 plus y2 over 2. Really, you can think about it as taking the average of the x's and the average of the y's, adding two numbers together, dividing by 2. Okay, so on 5a, I know I've got over 2, over 2. I'm going to be adding. I'm just leaving space to plug in what I need to here. What am I going to plug in for x1? 4. Very good. What am I going to plug in for x2? Beautiful. What about y1? 0 and y2? Perfect. Okay, so just plug in your x1, x2, y1, y2. Remember our ordered pairs always go x comma y, x comma y. You can put the 1s and 2s in there if it makes you feel better. Okay, then all we have to do is start simplifying it. What is 4 plus negative 3? 1. So I've got 1 over 2, comma. What is 0 plus negative 1? Negative 1 over 2. Will those simplify at all? No. So if you want to write them as decimals, you can, but I would just leave it positive 1/2, comma, negative 1/2. There is our answer. All right, let's try B. Again, using our formula, I know that I'm going to be adding a couple numbers over 2, comma, adding a couple numbers over 2. What's going in for x1? Negative 2. What about x2? Beautiful. Y1 and y2. Wonderful. Do we have any questions about where we're coming up with how to plug in what where? If you did it slightly differently, it could still come out okay as long as you're not putting a y with an x or an x with a y. You got to keep your x's together, keep your y's together. Okay. We take negative 2 plus 4. What do we get? 2. And 3 plus negative 8. Wonderful. Which one of those will simplify? 2 over 2 is 1. Negative 5/2. If you write it as a decimal, that's fine, but you can just keep it as an improper fraction also. That is it for our examples.